afternoon, everyone. My name is Jevtić, and I will speak about the mechanical characteristics of compressive specimens obtained by SLS technology. Based on the standards shown on this slide, powder bed fusion is an additive manufacturing process in which thermal energy selectively fuses regions of a powder bed. The most important powder bed technologies are SLS, SLM, and EBM. The principle of obtaining parts using these technologies is shown in figures 1, 2, and 3. This research describes parts obtained by SLS technology. In the SLS process, layers are joined using the fusion of powder-based material using the energy source. Each succeeding layer is applied with the addition of a thin powder layer above the already fused, one using a roller. Next, the laser beam passes over the defined cross-section, thereby fusing the selected material onto a previous layer. Therefore, material fuses in two of the following waves. Powder interconnects horizontally in the same layer and vertically in between neighboring layers. So the 3D printer used in this research is Fuse 1, and it shows in this slide along with its features. With this technology, objects of different shapes and dimensions can be produced at the same time. The only condition that must be met is that the models are at least 5 millimeters apart from each other. The thickness of the powder layer is 110 microns, and during the sintering process, one row of powder is sintered at the same time. Material included for use SLS technology are polyamides, polystyrenes, thermoplastic elastomers, and polyether ketones. In this research, one type of specimen is used for mechanical characteristics according to dedicated standard ISO 604. Compressive specimens are 10 with 20 millimeters in bulk. Compressive specimens were prepared in 4 batches with 10 specimens per batch. Batches differ in printing orientation and printing location. In this case, printing orientations are vertical and horizontal, and the printing location is on the edge and in the middle of the powder bed. After printing, the specimens were tested on the standard tensile machine. It is a Shimatsu AGS6 with a capacity of 100 kilonewtons. It enables very precise measurements with an accuracy of 0.5%. This device allows loading in the direction of tension and the direction of pressure. Depending on the type of test, various tools adapted to the desired type of test are used. The tools include clamping jaws for tensile testing and a 3-point bending tool consisting of pressure and supports, as well as compression plates for compression tests. The software used for data acquisition, example, method creation and testing itself is trapezium-X. Some of the characteristics of this machine will be shown in the following table. So the compressive strength of PA12 material is 13 megapascal on 1% displacement, 24 megapascal on 2% displacement, and 55 megapascals on 5%. This slide shows the results for horizontally printed specimens. The specimens were printed on the edge and in the middle of the powder bed. in both types of these specimens, there are large deviations in the compressive strength in relation to the values of the compressive strength of the PA12 material itself. The closest values were obtained at 5% deformation. These values are around 50 megapascals, while for material PA12, this value is 55 megapascal. Similar to horizontally printed test specimens, the vertical specimens also obtained values that are quite different from the compressive strength of PA12 material. The smallest deviations of compressive strength values were observed for vertically printed specimens in the middle of the powder bed. And the compressive strength value of the vertically printed specimens in the middle of the powder bed is 3 megapascals lower than the compressive strength value of the PA12 material. And conclusions, PA12 material exhibits different compressive strengths at various deformation levels, 13 megapascals at 1%. Displacement and 24 megapascals at 2% and 55 megapascals at 5%. For horizontally printed specimens at the deformation on 5%, the compressive strength values were 50 megapascals, and the compressive strength value of the vertically printed specimens in the middle of the powder bed is 3 megapascals lower than the compressive strength value of the PA12 material. Thank you for your attention.